Right, I've got the first item. So I wanted to talk a bit more about, I think, what I actually talked about last time, but I've been away for a week, so I've not been working on this for that long. So I set up, when we were doing the test to see what 1 queue per shard would look like in terms of whether that would be a valuable project to do, Craig created a pair of instances, or I think he actually created 3, but to simulate what we do with Sidekick on a Redis instance, and then say, okay, well, if we have 1 queue per worker and we have this many jobs for this many workers and they take approximately this long per worker, like what happens? If we have 1 queue per shard, what happens? So I'm just grabbing that and updating it to see what happens with different scheduled set permutations. I thought I had this set up before I went away, and then I came back and I realized that like a bunch of stuff was wrong and all my results were wrong. So that's what's been taking me the time so far, is figuring out whether my results are actually valid or not. I think I'm getting there, but I still need to tweak the actual total amount of traffic to get the right load in the first place. I'm going to share, well, I'm actually running one now, so that's a good example. So if I just spin this back a bit further. So yeah, one of the issues is like, I run an experiment, I want to leave a gap between experiments to see, you know, to make it clearer where the demarcation is. So we can ignore all of this to the left. These 3 here are with the new Sidekick 6 scheduler that we had issues with. So this is with no scheduled jobs. And you can see I've set the base load probably too high here, because this is 1. This is with half of all jobs being scheduled, and this is with 100% of all jobs being scheduled. And you can see there's no difference between those two, again, probably because the underlying load was too high. What is interesting, so I've made this a stacked chart to make it clearer, but I can make it unstacked, is that the user time was pretty much the same in both of those. It was the system time that went up. And if we look at the Redis exporter for those, we can see that it was similar to what we saw in production, where we have a huge amount of ZREM commands because of the way the Sidekick 6 scheduler works. And so a lot of that, I haven't taken any flame graphs, so I don't know this for sure, or profiles, but a lot of that is probably due just to the additional network overhead of running, you know, 175,000 commands a second or whatever I'm doing here. So yeah, then I'm trying to remember what these peaks are. So these peaks are with the new scheduler that Heinrich's put in that is atomic. So it does a single Z range by score and a ZREM if needed in a Lua script. This is, I think this was ramping up slower. So this was going, no jobs are scheduled, 30% of jobs are scheduled, 50% of jobs are scheduled, 70% of jobs are scheduled. And then I was like, wait, I don't have enough headroom here to see the difference. So I'm going to have to back out and reconsider. And the distinction here is that it's user time that's going up, not system time. So the blue peaks here, and down here we can see the rate of commands we're sending to Redis is much lower. This is Valshar, and then this is we should have as many ZADs as ZREMs basically, because ZAD means scheduling a job, ZREM means descheduling it, running it. So I'm just running one now as well. That's why this is changing when I click execute instinctively, because I want to see what's going on. So all I'm doing with that is now prepping to see what happens when we change to only scheduling from certain processes, so not scheduling from as many processes as we have now. And I can also, but I haven't done yet, look at I've got the Sidekick server logs available to me, so I can look at those and see what that does to scheduling latency as well. But like I said, most of my time on this week has been spent finding that actually what I thought was valid was not valid. Then thinking, right, I've totally fixed that, and then finding another problem. I think now I'm at a point where I don't have any problems, but I thought that on Tuesday and on Wednesday. So who knows?
Is that including the change that I think Heinrich just did? Well, I think you merged it, or did I merge it? I don't know, but the idempotent dropping, the idempotent scheduling, or what was it, like the Lua script?
Yeah, that's the atomic thing I was talking about. So that's where you can see the eval char.
Okay, cool.
So that's eval char here. So that's these.
Cool. Yeah.
So yes, that does include that. So I was just showing the difference between the two schedulers initially to show the initial difference. And now I'm looking at using the scheduler we have. If we do that in fewer places, what happens? But I want to make sure my results are actually correct first. So yeah. If there's no questions for that, then I think it's Bob.
Yep. Okay. Let me share my screen. I wanted to show how, like, we want to introduce the new customizable request duration app dex SLI to error budgets. It's already in the services. So the services are like have that SLI now, and we will use it for alerting and so on. That's already running. But we wanted to include those on error budgets for stage groups. Like, we wanted to give the people time to adjust their threshold on the endpoints that they have before feeding that in the error budget, and that's mostly done. How that'll work is I've added everyone here. Let's see, where's the stage group? Packages is stage group, and I've added the key ignored components. Components refers to the component label that we have on our metrics. And when you set that, that's going to result in these kind of rules. So yeah, what changed here is that now we're going to, instead, like this used to be just a rule that aggregates for all stage groups, but now we generate like a separate recording per stage group that, let me move this out of the way, that excludes categories that are ignored. Let's see an example.
You mean components that are ignored?
Yeah. So here we see the package group that has the Rails request component ignored, as we see here. And we do that, so separate recording for each group, and we do that by selecting here and then negating here. I don't know if there's any thoughts about that, because the annoying thing is that now we have this separate recording for each group. That's
yeah.
Thoughts, Andrew?
Yeah, the first thing is, where does the package label come from? Oh, is that coming from the...
That's the mapping.
Yeah, okay, there. Okay, because you could also just put it on the recording rule. It might make it slightly easier to, but it doesn't matter. On the, you know, as a label, as a static label on the recording rule.
That would have the same effect, yeah.
Yeah.
We would still need
that was just a confusion. But the bigger question I have is what's the, why did I missed the beginning? Why do we need to exclude these components?
We want to, so these are already included for service monitoring and so on. That's going to just stay the same. They are not included in error budgets, because there we wanted to have the, you know, the meta from source metrics, that's added here. So if you set this thing as a feature category on your SLI, then that's going to be part of the aggregation instead. So that's what's happening. When that's there, we're going to, the idea is to have recording rules for feature categories. For example, I don't know, yeah. That is going to have,
there's those labels that I was
yeah.
sort of similar, yeah.
So here we have the feature category and the aggregation rather than a static label.
Yeah.
So those metrics are like going to be, well, that's the idea, is that those are the source of the stage group metrics on the right, but the ones on the right are for error budget. So those will be adjusted, but we would still have the actual data in the component feature category metrics on the left.
So, and the reason you did them on the team is because some teams might want to include them.
Because some teams, well, right now we're waiting for teams to start setting thresholds. I merged the first merge request related to that yesterday, I think. And we want to give them time before feeding it into the budget. Because otherwise, if we just turn it on, then everything's going to be red and people are going
for
to be
everyone,
sad.
yeah.
So that's why it's kind of like it's opt out, but it's opt in.
Yeah.
Does it make sense? The reasoning there?
I think so, yeah. Like I haven't been looking at this a lot recently, but that makes sense. Why you want to do
the reason I did it. The reason I did it with these two, with this separation, so feature category metrics stay the same and stage group metrics don't, is I want to at some point build like a group overview dashboard, like we have the service overview dashboard that shows the metrics on the left, and then you can basically click on and off components using a template. I'm hoping that's possible. Like in my mind it is. So then you could basically see what things would look like if you enabled or disabled certain components from your error budget. And then you can remove the exclusion in the teams.yaml when you think that it's close enough. That's the idea.
Okay. Not directly related to this, but something that I've been trying to do in the engineering allocation meeting, and I want to bring this up because you might have a better way of doing it, is I've been trying to kind of like connect the budget to like the user experience. So every week what I do is I say, these are the 5 violations, and it's pretty hard to violate now with the aptics as it is, but we still get a few. And what I'm trying to do is kind of build up trust in like these numbers are real. And so I'll say like, here are the violations, and this is the user experience that people have, this is what it is. And one of the first things I do with that is I go and I break it down by feature category. So I take that number. I mean, maybe it will make sense if I share my screen and just show it to you that way. Where's the browser? Give me a sec. Yeah, I might as well just go in there. So we've got, this report, which has got all the error budgets goodness in it. And then you'll get something like this threat insights over here, right? Which is a violation. And then kind of what I've been trying to do is like actually work back from that to, hey, this is what the users are experiencing. Like, this is why this is bad. And so one of the things that I've been doing is I've been breaking it down by feature category. And it's basically taking your queries and then kind of rejigging them so that they're aggregated by feature category. Let's see if this works. And then I'll get a breakdown by that, and then I can go from there into further detail. And so in that case, I could see immediately that the problem was pages, and then it helped me kind of go into pages. But obviously, I've got like a lot of tribal knowledge that lets me put together this query and get to here, and then kind of go from there. The teams don't have that. I was wondering, there's nothing on the stage group dashboards that has this breakdown, is there? By feature category.
But the things, the SLIs have those significant labels, and feature category is one of them. So I want to build this thing.
Yeah.
Wait, I'm not sharing my screen. I want to build this thing that you can, but you know what I'm talking about. Well,
yeah, I'm sure to.
The thing that you can expand on the service dashboard. So you've got the service level indicators. Here is the, so I wanted to basically build the same thing, but for stage groups that uses those feature category metrics that are here on the left. So that's one that just shows the overall thing. Rails request should be in there.
Yeah.
Here.
And then you
have this one with the detail that expands by all significant labels. So the thing that you're showing with the feature category would be there.
Oh, there it is, per feature category.
Yeah.
Yeah.
So that's going to work. The thing is, on this dashboard is, like, as you can see, a bit too much.
Yeah. Can we do it per stage group?
I want to do that per stage, like per stage group would have a dashboard like this.
Yeah.
An extra one.
Okay. And then it wouldn't have as many.
As people start using the error budgets, but also as we start using the error budgets and the data that's been collected, I think we're seeing that there's certain like additional bits of tooling that would be helpful to have. And there's a couple of issues that need to be raised about that additional tooling and how that could be helpful. I think this is one of them.
Yeah, the attribution approach, right, where it's like ratio on the number of requests is also really helpful, because you could get something that, if you just, the way that I was doing it there, you might get a feature category that's like 50% or something really poor, but it's got like 20 requests a month. And the attribution approach, because it's taking the total error budget and like what percentage each subsection is.
Since that thing is just an aggregation set, I'm kind of hoping I can steal the entire thing.
Yeah, it's like a really ugly query.
Yeah, but it works every time.
Yeah, so that'll be super useful. But the other thing that I've been finding really helpful is like running that little exercise. And I unfortunately I've only got 30 minutes before that call to do it. But I go through it, and pretty much every week I find like one or two new infra-dev issues. Because I just go, I'm basically starting with the error budget, and then I'm going backwards from that to like, what's the cause of this? And there's like always new things. And one of the PMs said to me, like, you just seem to be finding all of these bugs that we didn't know about. And I thought that was such a nice comment, because you seem to be front running our bugs. And it's purely down to those error budgets, right?
Yeah, I think
that's not even front running the bugs that's important, because you
can
do that just by
front running them, discovering them. Yeah,
it's the important ones, the ones that hit often. Yeah.
I think it's going to be cool when they can see their budget in like a shorter term that's not 28 days, because from there it's very hard to go back to what happened.
Yeah.
But if they can see like 6 hours.
Yeah. In the call, they keep saying, well, we don't know what's happening. We've fixed this thing. We don't know what's happening yet. And I keep wanting to go like, just run this query. It'll tell you. But it'll be much better if it's just in the dashboard.
When I review things like that are related to stuff like this, I tend to like drop the Thanos link in, and like, when this is deployed, click here to see the effect.
Yeah, it'll be good to just get it in there, because you'll hear like directors going, we're waiting a few weeks to see what the result of this is. And I'm like, we don't need to do that.
Kwang Min, I think you had the next thing, unless there's more comments or IDs or anything.
Okay, so it's my turn. I will share my screen. So Greg and I have been working on the interesting issue for the last 2 weeks, and it is about evaluating the different approaches to scale up our Redis instances. And we are trying to capture the production traffic and then try to raise a raw test to test different approaches, different systems to serve our production scale. And it is a little bit different from what we have been doing before. And because we are trying to evaluate the data using Redis on top of Redis cluster, the key distribution is really important. So that's why we really want to capture the erosion level work loss, and then we try to capture the key namespace, the data size, and even a set pattern of each key, and so that we can generate the erosion traffic. And we just it's not only about the traffic or the request rate, and it's all about the key distribution and the command we use to access to each key. So what approach we're trying to do is to snip into the Redis instance and try to capture the Redis traffic via the tcpdump command. And Igor already have really an excellent guideline how to do this. So basically, after we snip into the Redis instance, we are trying to generate a pickup file with tcpdump, and then we use a simple script in the runbook to analyze the traffic, and then we can get a full list of keys by commands we are trying to run against the Redis. And Rock and I are working on this on top of that, and we got some progress that we refactor the script to capture not only the request but the response as well. The original script doesn't have the response, so we have to match the request and response and to analyze the data. So from the pickup file, we split on the file into a folder of smaller files, and each file contains some kind of the raw data from Redis, and this data is generated by the Redis protocols. And for each request, we have two files, one file for the request and another file for response. And in each file, we have an index file, and yep, that's it. And we have to pass the request file to get the no, it is the response file. So we try to pass the request file here and with the Redis protocol, and then we try to look up back to the response file with using the timestamp here to match the response. And after that, we can generate something like this one. Yep. So basically, we try to reassemble the on the basis from tcpdump data back to the data, and then we try to generate the key pattern files from this one. So after this one, we got a file look like this. So in this file, it contains an array. It contains a hash of the key pattern, and for each key pattern, we have a value size, which is the data size we set into Redis, and response size, which is the size of the responsive we receive from Redis, and some other data. On the bottom one is the unique key frequency, which is the distribution of the key upon a pattern, and the total usage of the key. So from this data, we try to analyze and have a big picture of what we are trying to do. So I did some analysis on this, and when we capture about 30 seconds of data on erosion traffic, we get about 600,000 requests, equivalent to 20,000 requests per second. And then we get the overall picture of the erosion traffic. And from this data, we are trying to push the file into a load test system, and we're using cases.io right now to generate a load test. So basically, it allows us to write a load test and based on the a set of scenario. So it has some cases. Okay, the scenario looks really simple like this. So it allows us to declare the scenario in JavaScript, and then we will run the system against our Redis instances. However, it doesn't support the Redis out of the box, so we have to write a thing adapter on top of Golang to plug into this JavaScript scenarios file, and then we try to run that, and the result is interesting. So let's say the testing script is really simple. It's not that simple, but we will pass the file, the key pattern file there, and try to translate the key pattern into different scenarios. Each scenario is a combination of the command, the key pattern, and then we try to repopulate the data before we run the loss test. And after that, we will buy the pattern to issue the real command against Redis here. So we implement a thin adapter in Golang. Right here is just a really thin adapter to block our command and issue a real Redis command. And after that, we just need to run the load test file, and it will perform it automatically for us. So before we do anything, we will populate the data and generate random keys based on the key frequency. And after that, the cases will were about hundreds of clients, and then it will issue the data with different iteration speed. For example, we generate about 300 of scenarios, and each scenario is a combination of command and key pattern here. And each scenario has different speed. So for a full production traffic, we have about 300 scenarios. And after we run the scenarios, oops, okay, connection refused. Oh, sorry, I forgot to start my Redis server. Okay, I will run the script again. And wait some seconds. It is the population step, and we try to predict and populate the data into Redis before running a loss test based on the response histogram and the key distribution. In the example, I'm trying to run the load test for 30 minutes with the multiplier by 5. It means that I'm generated 5 times bigger than the production traffic. I'm not sure my computer can handle that traffic. Okay. Good. So after running the loss test, we can see that I'm issuing about 45,000 requests per second against my local Red instance, and then I have some metric for each command issued, and on the distribution that matches the one we capture on version. And for each command, I have a set of metrics, histogram metric here to see whether our histogram is satisfactory to what we want to when we scale the Redis instances up. So we are moving into the last step of this issue, and after that we bring up different Redis instances and Redis cluster and run a load test against that with different settings. So yeah, that's it.
That's awesome.
Thank you.
That's really cool. One question I had, what kind of environment are we running these tests in? Do we provision like dedicated machines and have a separate machine for the client versus the server?
Yes, we will provision about some client nodes and run the load test against that. One good benefit of this approach is that because on the load test is in the code, we just need to run the scenarios and just run again in different nodes, and the test will just run. We don't need to too many manual works.
Just one environment. I've used K6 before, and I think it's a super cool tool. Is the JavaScript execution environment Node, or is it just like a vanilla JavaScript?
It is an interesting question. So it is not yet under JavaScript environment. So we cannot use an existing library. So it is basically written in Golang, and then it will translate the JavaScript into the Golang runtime, and that's why we have to write a JavaScript binding, the Golang binding for JavaScript, and we have to rebuild the binary in order to run the script.
Okay, that was kind of where my question was going there. So that's interesting to know. Thanks.
Yeah.
All right, I guess I have the next one.
Yeah, your turn.
So I've been working on a little script that basically runs through the install of the Helm chart and then does an incremental upgrade. And I've tried to match the configuration to what we have in production as well. So this is basically the script. So it runs Helm install and then Helm upgrade. And this is sort of the config that I tried to match as closely as possible. So if I run that, it's first going to do a dry run, kind of give an indication of what it's going to do. So I'm just going to say, go ahead, install that. And we should start seeing, we've got K9s running here. So we can see the first pod coming up. I've got Stern for tailing logs in Kubernetes here. And we can see the pod is starting to come up, but it's waiting for its own IP to appear in the Kubernetes service. So there's some logic there for it to kind of wait for that to propagate. So now it came up. The pod has both Redis and Sentinel. So this is matching what we're running in production right now. And so that's the first node. We see the second node coming up. It's kind of doing the same dance. So it takes a couple seconds for each one to come up because of this. Yeah, I guess we can wait a sec. Okay, and there's the third one. And these are being managed by stateful set. So it's kind of relying on Kubernetes to do a lot of the heavy lifting. And I guess if I look at one of these, you can also see the two pods or the two containers per pod. So let's see where we're at. Okay, so we're now up and running. And so the scenario that I want to simulate is upgrading the Redis version. So we're going to simulate an upgrade, and it's going to set the image.tag to the +1 Redis version. So we'll do a Helm diff first, and indeed we can see it's kind of proposing to update the image. And the other important change that it's doing here is it's setting the partition on the update strategy on the stateful set. And this is the Kubernetes mechanism for isolating a change that you're making to a stateful set. So basically this is saying, do not apply this change to any pod with index below 2. And so we've got 0, 1, 2. So it'll only apply the change to this pod, and it'll keep these two on the older image. And that will allow us to roll out the change to only one, test it out, see if everything is working, and roll back if needed. So we get more control over the rollout.
How would we, can we manually fail over to make a different one the primary with this?
Yes, there's some caveats with that I'm still trying to figure out. So I can actually maybe try and demonstrate that. So, starting a Redis client container and then using this to connect to that container and triggering a failover.
Mm-hmm.
So, okay. So that was a failover. Looks like in this case, it worked fine. Let's see. These always spam a lot of text, so it can be a bit tricky to see exactly what happened. But I guess we failed over from node 0 to node 1.
Yep.
And yeah, looks like that worked fine in this case. I've had some tests where this puts it in a weird state and it takes a while to recover. And
Okay.
So I can try and do another failover and see.
The opposite of a normal demo where it works better.
This is it. So
okay.
This is basically node 0 and node 2 are now both trying to connect to node 0. Like node 0 is trying to connect to itself.
Yeah.
But it hasn't it hasn't stepped up yet.
It doesn't think it's the primary, but it's trying to connect to itself as the primary.
And so it kind of takes it a while, but usually after, I think it took like 20 or 30 seconds in previous tests to kind of recover. Okay, so let's see.
I see a full resync mentioned at some
point. We've also got next failover delay. So it's kind of not deciding not to do a failover yet because it doesn't want to do too many failovers. So node 0 is still trying to connect to itself, but I think we promoted a different one. Yeah, I think we promoted one to be the primary again, maybe. Yeah, in any case, this is sort of weird behavior, and it usually takes a while for this to kind of fix itself. Sentinel does.
It's because Sentinel. It's because Sentinel. When the server reports itself, it reports with a different IP as to what Sentinel sees it as, right? Or as a different host. Something along those lines.
It could be a mismatch between like the host name versus
different
the
addresses.
Because it could be something related to that. But you can see here now, after like 40, I don't know, like half a minute or so, Sentinel noticed that something is off, and it does this fix slave config thing and sort of fixes itself. And now we're in a good state again. So at least it recovers eventually, but it's still not really nice to have this weird behavior. So I want to dig into this.
And during that time, like the system as a whole is still like able to like serve requests, right? Like there is still a primary. It's just not the one you intended to fail over to.
I think so, yes.
Okay. The other question I wanted to ask was, first of all, this is really cool, thank you. The other question I wanted to ask was, what was it? Oh, resizing. So presumably this makes things like the resizing we had to do a while ago simpler as well, where we needed to make Redis persistent have more, well, disk, but I guess that's handled by the other things in Kubernetes. And then also memory. I guess this makes that a lot simpler because it's just sort of like that's a regular thing you do in Kubernetes or can do in Kubernetes.
Is the operator flexible enough for that, where you can say, I want to resize or change one thing in the cluster and not everything at once? Because
we're not using an operator here at all.
Okay. Yeah, so I just dropped in.
So the partition, I can maybe just so you see that as well. We're using stateful set, and we're using the partition mechanism on stateful set. And so the example that I showed was using that to update the image on only one of the 3 pods, but we can apply that to any change. So that also applies to updating requests and limits on the pod.
So this specifically allows us to have heterogeneous Sentinel deployments, because that's what you need do these sort of upgrades, right? You need the
Yeah, we can do one
configuration
at a
management
time.
system needs to understand that it's not just, because that's one of the things I find difficult about understanding our Gitly server Terraform config, because it just says the Gitly servers look like this, period. And it's not very clear to me how you make changes to that, where you account for not everything can change at once, or how does the change work?
Mm-hmm. Yeah, and this is kind of the built-in mechanism in Kubernetes
nice.
to handle that case. Yep.
Seems like you're on your way to building an operator, Igor.
We'll see.
Yeah, but what was I going to say? Is it possible to run Kwangmin's load testing during your upgrade as another pod, as another thing running in the cluster?
Should be doable, or I guess it could also run externally. Yeah.
But just as a way of measuring like how rough the failover is, right? Or how rough the upgrade is.
Yeah, I do have a sample workload as well that basically just counts up from 0 and adds that to a list. And so we can look at list length and we can look at the last element, and that'll give us an estimate of how many writes we lost.
Oh, right, yeah. Clever.
Yeah,
it's not just about losing writes, right? It's the reads are also. Is there a situation where reads still work and writes fail?
Yeah, reads should remain available due to the way that the Ruby client handles failovers. So on failover, we'll either get some stale reads from the primary before it steps down. Once it steps down, it closes all connections to all clients. And so the clients will reconnect. They'll go back to Sentinel and rediscover the new primary.
So is there a new primary instantly, or is there a window where the clients ask Sentinel and Sentinel doesn't know?
There is, in our current configuration, there is a new client, a new primary already present before the step down. So it's like the Sentinels agree on who the new primary is, and then the step down message goes to the old primary. And so there's a window of stale reads in between, and potentially lost writes as well, because we're writing stuff to the old primary that then gets thrown away. But the new primary is known at that time. So reads remain available.
Because you're issuing a failover to Sentinel as the first step in the process. Like a Sentinel failover.
Yeah, either that, or we could shut down, like if node 2 happens to be the primary, we can shut down that node and Sentinel will elect a new.
But there's a if I remember correctly, there's a longer delay if you do that. It kind of like goes like, hey, are you there? Are you there? Are you there?
Yeah.
And then
it's
okay,
it's
I'm
a
going to
10
switch
second.
over.
Yeah,
okay,
10
seconds,
timeout.
Yeah.
So that could induce some read unavailability. Yeah.
I generally think it's better to have some availability, but a system that behaves in a predictable and reliable way than I think a small amount of unavailability is a reasonable price to pay if it makes your system more reliable and predictable. And I think sometimes in discussions about HA, people have expectations of everything has to be available 100% of the time. And then you can work yourself into a corner. And if you accept that a controlled amount of lost writes or lost reads or whatever is part of doing business, then you can design better systems.
Sounds almost like an error budget.
Yeah, I suppose it is. Yeah. I can give a small update because it's quiet and I'm just butting in. I can give a small update about the final tag stuff that I talked about 2 weeks ago, I think. So I demoed something here, and we looked at, and it was just the speed improvement was pretty surprising because it was end-to-end 6 times faster and it used 9 times less resources on the server. And then after a while, we decided to just take the proof of concept and submit it as proper code. And that met resistance from the GitLab team because they felt it was making too big of a change to their architecture. That resulted in a bit of a stalemate where we didn't know how to move that merge request forward. But yesterday, the GitLab product manager, Mark Wood, got involved. And I impulsively thought, let's just have a call and see where this goes. And that turned out to be a very helpful conversation. So what I'm going to do now is I've been approaching this as fixing one little thing, but it's really a pattern. There's a lot of RPCs that follow this pattern that is inefficient. And I guess that's also where the friction comes from, because I'm breaking that pattern. So what I'm going to do now is write a sort of short document where I explain what the pattern should be, I think, and see if we can get buy-in on that, or if that makes it easier to sell the idea. And Mark offered to help me write that or give feedback on how I write that and like what needs to be in there. Or so it's not like I have to write a document that and I don't know what the requirements are. That's, yeah, that's not the approach I chose, obviously, because I thought just from a technical perspective, let's just go in and do the least amount of work and fix the thing. But I'm happy to paint this picture and see see if people like this. So that's the next step there. And I think it kind of makes sense because the pushback had to do with the architecture. So if maybe I just need to sell the architecture first or do more work on that. And what related is that Stan Hu and John Kai have been, well, actually, a number of people identified the likely source of the bad traffic on file 43, and they created a new GitLab RPC that solves this one problem. And we never quite got to the bottom of if final tags is really every time the main cause of the trouble, but it seems to be a lot of the time. And that new RPC got enabled like 1 or 2 days ago. And I think it's been a bit quieter since. So if we're lucky, that one particular problem got solved in a different way. And I still think we should do something about final tags. And there's other RPCs that have the same problem. So I think that the thing I built a proof of concept for and the idea I'm trying to sell is still worth selling because it's just better for everybody involved, but that would remove the urgency and change the nature of the conversation. But we still have to see if file 43 is now less of a problem child, because it seems to happen like a couple of times a week, and it's only been, the change has only been live for 1 or 2 days, so that's a little bit too soon to say it's definitely fixing it. And just as a quick sketch of what the bigger pictures that I'm trying to sell is that in the current model, we have RPCs that have a certain design, which is inefficient, we now know from a computational perspective. It puts a maintenance burden on the GitLab team. And when teams like create source code want to build new Git features, they need to build new RPCs all the time. And every time something is not part of the big abstract interface, the interface needs to be expanded. And I think what a better approach would be to say that most GitLab RPCs are very thin wrappers around Git commands, and GitLab streams the output as is to the client, because then if the client wants to parse another piece of the data, then they don't have to ask Gitly to send another piece of the data because they get all the data there is. And another thing that is not strictly about performance, but that is about lower maintenance overhead is that I think that these RPCs should just expose Git command line options as is. And Gitly should still validate them, so that because some command line options are bad, we shouldn't allow clients to run arbitrary commands. But now we do things like we have protobuf definitions to say how you can sort tags in find all tags. But what's really happening is that there is a sort flag on the git for each ref command that takes a string argument. So if the client can just put that string in, then they can sort on any field they want. And that's just less work than to have to come back in and say, oh, now we also want to sort on this attribute. So let's update the protocol and update the RPC and ship a new Gitly version so the client can sort on another field. When if instead they can just pass the sort argument that Git already supports, then that saves that removes unnecessary friction for the client, meaning create source code to develop new features. Does that make sense?
It's broader than create source code, but yeah, it makes a lot of sense, I think.
It does sound a bit risky in the sense that we have less control, or we, depends how you say we, but with a broad interface, there is less control on the allowed set of combinations.
You can still, you'd have to validate them anyway.
Yeah, I think like if the thing that engineers need to add, if they want to add a sort by author thing to the find all tags, then like if they need to add author to one of the allowed things, then that's, well, acceptable, I guess.
I don't think it's necessarily about having less control. It's more about whether you want to define everything that is possible in the protobuf definitions. The protobuf definitions sort of act as a type system. And you can say, well, I want to lock everything down and this is everything that's possible. But then what you end up with is a protobuf definition that looks like the Git manual page of a command, where all the possible values of all the possible flags are protobuf fields and constants. And yeah, I think it makes more sense to say you're allowed to pass flags, and then there's an allow list in Gitly where we say if it becomes a runtime error, right? Like, is it if you encode the information in the type system, then you cannot make certain calls because it's more like a static thing.
Right.
But yeah, you're doing this across repositories, and you need to have merge requests in multiple repositories. Wait for a release to be integrated back in, and by making it a little bit more dynamic and pushing some things to the runtime level, I think you remove friction. But yeah, we definitely need to validate. That's not a question.
I guess the analogy that I have in mind is kind of like GraphQL, where you really have a lot of flexibility in the types of queries that you send. And maybe that's a bit of an extreme example, but it generally makes the RPC performance much less predictable.
Yeah,
or can at least.
Yeah,
so that's kind of where I'm coming from.
Yeah, that's what we're doing with GraphQL now as well, is measuring performance differently, so it is kind of predictable. Like, don't measure request duration anymore because anything can be in there. But if you make a distinction between what's happening, then you can measure it again because you.
Yeah, I think GraphQL is a more extreme example because you can make very wild combinations of, I want to get all the X and all the Y, and I want to have this 100 deep and 1,000 of that. And you can make an arbitrarily complex query. And if I say, I want to run Git for each ref, and I maybe can add some sort flags, or I can say, I only want the refs that contain this commit, then it's much more bounded how much complexity there is, what the client can ask of the server.
So another Yeah, another fairly successful API with a service with the API like that is SQL. So, you can put anything in. It's pretty open-ended. And, in a way, it's the same sort of thing that you're talking about, right?
Yes and no. I think SQL is in a way more like GraphQL because you can do anything. It's
yeah, that was my point.
yeah.
It's like,
And as we know, that is great, but it's also a problem
it's
because
good and bad.
Yeah, because you can have SQL queries that are absolutely horrible. But this would be more like you have an API that allows you to do a select on a certain table. So it's never going to be worse than whatever you can do with a select on a given table. And it's not a perfect analogy, but what I'm trying to say is I'm not suggesting to create a system where people can glue arbitrary Git commands together and just see what comes out, because it's very hard to make that secure. And yeah, then you end up with a completely opaque system. But in practice, we have, I haven't counted yet, but we probably have 4 or 5, if not more, different commands that are all variations on git for each ref. So different RPCs that call git for each ref with slightly different flags. And if you just have one RPC that gives you the output of git for each ref, then you can deprecate a bunch of old ones, and you don't have to keep adding new ones, because the RPC that got added to address this problem on file 43 was yet another variation on git for each ref. So if we would have had a generic git for each ref RPC, we wouldn't need a new RPC. At worst, we would have to tweak the allow list of the generic git for each ref RPC to say the client is allowed to use this flag. And I think if that's all that the RPC does, then the code is shorter, the tests are shorter, there's less to test. All you need to really prove is that the flags get applied to the command. You don't have to prove what the flags do, because that is Git's job. And yeah, people can on the client side can iterate and build features without having to make fewer RPCs in between. I mean, there's also these ridiculous things like we have these RPCs to find all new LFS pointers. So what we do is we run git ref list and we look up all the blobs that it enumerates of size less than 200s. So that you could just have a thing that says git ref list return blobs up to a size. But then we have special RPCs that tweak the argument to git ref list by Wangmin, that tweak the arguments, and Gitly tries to filter the blobs to see if they look like LFS pointers. But then on the client side, we parse the blobs again to make sure they're really LFS pointers. And if you just have an RPC that sends all the blobs that are less than 200 bytes, you can have a generic RPC where you say, give me all the blobs in this repo that are less than 200 bytes. And then these different variations just, you don't have to maintain them anymore. So there's a bigger picture here, and it's not just about performance and resilience, but also about developer convenience. But I think there's also more advantages for us, because if you think about something like Git upload back, the reason that doesn't completely explode on us all the time is that the clients receive back pressure, or the clients exert back pressure on the server processes. But if you do clumsy parsing on the server, you do extra work, then you can make a cheap Gitly call, and then the Gitly server goes bonkers trying to parse all the tags and fetch them from Git in an inefficient way. So you get this leverage where cheap requests cause expensive replies or expensive server-side work. And if the server is really dumb and it just sends back a byte stream, then in most cases, the client will exert back pressure on the server because it has to consume the byte stream. So the Gitly server just has an easier job. And there's also the fact that if you want to do something like C groups or limiting, it's much easier if you know that all the workload happens inside the process and not there is X overhead. Like the Git process is doing some work, and then there's a chunk of overhead in the Gitly process that we don't know how to quantify or limit. So it's just a simpler model. Anyway, thanks for listening. This is something that's in my head now, and I need to write down, and telling you about it helps me find out what the story is.
GraphQL for Gitly.
That is definitely not the story. As far as I'm concerned, I'm not going to say that.
It's good you're not trying to rip out gRPC.
Well, I still want to do that too, but I think that's I'm going to give them a break, or I don't think it would go down well. Also, I don't think it's the most important problem to solve right now. I think that the badness of gRPC was amplified by the volume of traffic of git fetch, and I think that it really is better now. So it's just not the impact isn't as high. But if you want, I can tell you how I would rip out gRPC without anybody noticing. Thanks for listening.
Have a good day, everyone. Bye.
Bye.